Thank you all for coming today. A very warm welcome to everybody. I think we've had over 2,000 people sign up for today's webinar, which I think demonstrates the high level of interest in this topic. So how are we going to structure this? We're going to start off with me just giving a few minutes by way of a brief introduction, setting the scene essentially, before handing over to James, who will introduce Ray's, and Ella, who will then cover applying Ray's recommendations before introducing the new joint AI methods group. And hopefully we'll have plenty of time for questions at the end. So why do we need to embrace AI? Well, health-related evidence synthesis has been around for some time and is based on the core principles of rigor, transparency, and replicability through systematic methods. And the stakes are high because decisions about people's health are made on the basis of evidence synthesis. But as we know, the field faces some huge challenges, one of which is overload. With thousands of health-related research articles produced each week, the sheer quantity of evidence being produced makes it difficult to keep pace and gain a true understanding of what has been done and where the gaps remain. This deluge of research presents those of us trying to identify it with a huge specificity problem. With the emphasis being on not missing relevant studies, our sensitive approach to searching means that, as one colleague put it, we're often trying to pinpoint needles in giant haystacks. Coupled with questions becoming more complex, sensitive searching is resulting often in overwhelming numbers of noise to have to sift through. And in addition to this, our ways of working, both in terms of processes and tools used to produce health evidence synthesis, are not conducive to making research as findable or as reusable as it could be. Issues such as lack of data interoperability, poor audit trails, teams working in total isolation, all hamper the production process and lead to duplication of effort and research waste. And ultimately, important questions remain unanswered, while others are answered again and again, wasting time, money, and human effort. So the largely manual process of evidence synthesis has essentially become unsustainable. Over the last 3 decades, we've seen a lot of change in terms of technology's role in health evidence synthesis. Artificial intelligence is an umbrella term, and it means different things to different people. In its broadest sense, perhaps we're thinking of it in terms of ways to automate tasks and activities currently performed by humans. And the aim to maximize the use of technology for this end is not new. It's been the aim of groups like the International Collaboration for Automation of Systematic Reviews, or ICASA or ICESA, for over a decade now. And thinking in these broad terms, we can see that forms of AI have been around for some time. It's had at least a 70-year plus journey, starting with things like text analytics and rule-based systems, natural language processing. And then we get to machine learning, both supervised and unsupervised. And we do have some examples of successful implementation of supervised machine learning classifiers, for example, the RCT classifier. And they have had an impact and do represent a nice example of successful implementation and community uptake. But of course, now we also have generative AI, which is a form of machine learning, but feels distinctive and significant enough to warrant its own bubble here. The generative AI has gained a huge amount of attention across the globe and in every sector. Is the excitement and the hype justified? Well, there are some obvious potential advantages. So generative AI uses large language models, which have been trained on vast data sets. And these large language models are able to recognize, summarize, translate, predict, and generate text without any specific task training or with only a few instructions in the form of prompts. There are some obvious potential advantages, including the speed with which these models can perform tasks, which then offers the ability to scale substantially, as well as the ability to tackle tasks in the evidence synthesis process that traditional machine learning has struggled with. Essentially, LLMs, or large language models, have dramatically opened up the potential task space in which automation or semi-automation could play a role. And I haven't mentioned accuracy yet. So we talk a lot about AI needing to be as accurate as the so-called human gold standard. Implementation of AI, of course, needs to not compromise on accuracy. In fact, in certain modes of implementation, AI might even prove to be more accurate than the human-only approach. And here I just want to flag a recent study that highlights this quite well. It's a SWA, so a study within a review, conducted by Cochrane and colleagues. And instead of using the human-only data extraction as a gold standard, they ran a head-to-head comparison with blinded adjudicators to compare traditional dual human extraction with AI plus human extraction. And the results are interesting. So the AI-assisted approach had fewer incorrect extractions, so 9% versus 11%, and similar risks of major errors, 2.5% versus 2.7%. And compared to the traditional human-only method, the median time saving of 41 minutes per study. A recent paper by Lieberman and colleagues aimed to provide an overview of large language model applications in systematic review conduct in health research. It's a great paper, and one of the figures in it is this one, which aims to provide or show the different studies evaluating the different stages within the review process. The green circles show validation studies, the grey are other study designs. And along the vertical or y-axis, we have the study author's conclusions, which this team have categorized into three main classes: promising, neutral, and non-promising. And according to Lieberman and colleagues, when it comes to search, we can see a definite sort of cluster of studies, and we can sort of see that deemed perhaps not yet promising at this stage. However, two of the most promising areas, the purple circles, seem to be screening and data extraction. As with all new technology adoption, there are always challenges, and large language models present some interesting ones, such as model overfitting, algorithmic bias, black box predictions, and hallucination. But in addition to these technical challenges, we also have a number of barriers to effective implementation, including, but not limited to, AI literacy, access, ethical issues such as environmental impact, and the fast pace of development. And on that last point, the sort of sheer pace of development raises some important questions about how we make the most of AI in evidence synthesis. The technology has the power to both transform and to disrupt. And sometimes it can be used to improve existing processes, and I think probably the vast majority of evaluation studies coming out at the moment are looking at that. But every now and then a new technology comes along that has potential to change or disrupt the existing paradigm, so to make tasks or activities no longer needed. Where does generative AI sit on this scale? It could radically change the way we produce evidence, but there are a lot of unknowns. And so I'm going to just conclude by saying I think we have a responsibility to use AI, but only if we can use it safely and responsibly. We'll be more effective at understanding and overcoming the challenges together, both at a methodological level and at a data level. To do this, we need guidance, frameworks, and infrastructure that enables us to learn and evolve as the technology itself learns and evolves. And on that note, I am going to pass over to James.
Thank you. Okay, so thanks for the introduction. I'm going to briefly talk us through this new guidance for responsible use of AI in evidence synthesis called RAISE. And I should give us a little bit of background, first of all. A few of us have been to various meetings and webinars over the last year or so. And lots of people said, what we need is guidance on these new tools. How can we use these new tools? And we thought, yeah, that's true. We should write some guidance. That would be helpful. So we went away and did some homework in order to try and write the guidance. And we found actually it was very difficult to do. Basically, the main problem was there are a lot of new tools out there, lots of tools being developed and marketed at systematic reviewers for use. And the evidence base on which to write guidance for their use is very thin to non-existent. And we were finding that the pace of tool development was vastly outpacing both the ability of us to keep up with validation studies and evaluation studies, but also the tools themselves were not being, the tool developers were not evaluating their tools. And so it was really difficult at the beginning to say, okay, so this tool is safe for use in this context, and this is a good idea to use this tool in that context because we just lack the evidence base. And this is an ecosystem challenge. What we have at the moment is an awful lot of energy, an awful lot of enthusiasm, and it has to be said, an awful lot of hype, a lot of money going into generative AI tool production. But what we lack here is really a solid foundation for basing decisions about use. So after having discovered that we needed an evidence base but we didn't have one, we started to think about, well, okay, so what do we need to do to move from this position where we are at the moment of having lots of interesting tools, lots and lots of development and enthusiasm, but no evidence to support its use. And we also were finding that there were tools that were being developed, and I'm sure we've all come across some of these tools that are being developed, which are running counter to a whole heap of evidence which has underpinned evidence synthesis for the last 30 or so years. And so there are big issues such as publication bias, which we've investigated as a field over time. We know what it is, and we know the steps that we take to minimize those kinds of biases. But some of these tools that are coming through now magnify publication bias, for example. And so there's a need to connect both ourselves with an evidence base and to develop an evidence base, but also there's a need to connect the people who are doing the evidence synthesis work with those who are producing these tools so that we can have a better fit for purpose in terms of tool development and the context of use, in this case, reliable evidence synthesis. So as Anna said, we do need to support this wider adoption of AI because we're basically drowning in research at the moment. We can't do evidence synthesis at the scale and the speed that we need to be able to do it. But we also need a cross-field standards. We need an evidence base. And in order to do that, we need to start thinking about how we can work together on it. And so we've evolved this concept of this ecosystem of roles. And you can see in this graphic here that a colleague of mine, Caitlin Hare, put together, which articulates these different roles. There's people who do evidence synthesis, the evidence synthesists, as we call them, so it fits in the box here. There are methodologists who develop best practice guidance for evidence synthesis. There's the people who develop the tools. There's the people who fund both the evidence synthesis and tool development. Organizations such as Cochrane, that produces the evidence synthesis, people who train people who do evidence synthesis and who are interested in the field, users of the evidence syntheses, and the publishers of evidence synthesis. And so the way that we've understood this is that each has a role to play in mutually supporting one another to build this ecosystem where we build an evidence base, a cumulative evidence base, but also where we engage with tool development, and so that the tool developers themselves have more security in terms of what they need to develop in order for it to be used in production. Critically, though, one person or one organization may play multiple roles at any one time. So, for example, I do evidence synthesis. So I'm an evidence synthesis. Some of my time I'm a methodologist. I do work in evidence synthesis methodology, and I wear that hat when I do that. And sometimes I write Python code and I'm involved in development. And so at that point, I'm in a team. So it's in a development team. So it's quite important that these are not individual people. Sometimes people will play different roles, but it's actually quite useful to sort of separate the role that I'm playing at a particular point in time from the range of roles that I might play within this ecosystem. So what I'm going to do now is I'm just going to go through in a little bit of detail just two of the main roles that we've got, no doubt, on the webinar today, the evidence synthesists and the evidence synthesis methodologists, and also organizations producing evidence synthesis like Campbell and Cochrane, JPI, CE, and the like. So thinking about the evidence synthesis, those of us who are reviewers or authors of evidence synthesis systematic reviews, and one of the sort of like the bottom lines that we've always got to come back to is that we are responsible for the evidence synthesis that we conduct. Whilst we may use different tools, we may work as part of a team, it's our name that's on the review, and we have to be accountable for what we've done. So it's no good sort of hiding behind an AI tool and saying, oh, well, the reason that I missed half of the studies in this review is because I used that tool. It's my choice to use that tool, so I'm responsible for it. And part of that, when I'm using one of those tools, is to report transparently how I've used it, and as well as transparently saying how I've used it, to justify why I've used it in that way. What is the evidence base that underpins my decision to use that tool? If I can't cite an evidence base which says to an external reviewer, yes, this was a valid and responsible use of a tool in my review, then the peer reviewer shouldn't pass the paper as peer review. I've got to be able to justify why I have a good expectation that the tool will perform as expected in my review. There's a lot of legal, ethical, regulatory standards to consider when we're considering using a tool, and also when we're using tools. There are various copyright issues which are quite complicated, and there's sort of terms of use of both tools and of databases and that kind of thing. So this is an area where the legal context is quite complicated, and also in terms of regions, and different organizations have different standards and contracts with different suppliers. So it's quite important that we think about this before sort of jumping in and using a tool. And also there are some particularly important ethical issues around the use of some of these tools from some of the suppliers. One of the oft talked about issues is around the way that a lot of these large language models have essentially been generated off vast quantities of data scraped off the internet without the publisher's permission. There's ethical issues around that, but there's also ethical issues around the way that they've been trained and also the biases that they've encoded. And so we need to consider, when choosing a tool, and look at the degree to which different tool developers have actually engaged with some of those issues, not least of which, of course, are the environmental issues in terms of the cost and the carbon imprint of some of the large server farms that are being established at the moment. So the bottom point number 4 on contributing to the ecosystem is something which all the roles have got, and the evidence synthesists within this ecosystem have a really key role, obviously, in terms of trying tools, getting feedback on tools, but also data. We are all producing lots and lots of data as evidence synthesists, and that is actually really important to developers in terms of developing and validating new tools. So if we want good tools fit for our purposes to be developed, one of the things that we can do is to make sure that we share our data whenever possible with developers, so that they can understand the sort of like the accuracy that we're looking for, and they can test and validate their tools. In terms of methodologists, so those of us wearing a methodology hat, there are open science practices which we should try to adhere to when carrying out evaluations. And so that's easy enough sometimes for those of us in an academic environment. But remember that the roles are not people. These are roles that are being played. And so when you're a tool developer and you're validating a tool, you are actually playing a methodology role at that point as well. And so what we see an awful lot at the moment is sort of validation and research studies which are basically marketing. They don't adhere to sort of even standard principles of open science. You can't replicate some of these research studies, or so-called research studies, which are being put out there. And so one of the things that would be really nice to do would be engagement between evidence synthesis methodologists and people developing tools, and trying to get a little bit more science into what at the moment looks more like marketing in terms of research and performance statistics on some of the tools. So we want to carry out these objective and impartial evaluations. And in order to do that, we need to build a cumulative evidence base. And so what we've got at the moment is a situation where we've got lots of individual studies. So, I'm not knocking them. They're very good, a lot of them. But they're isolated. They use different data sets, ask different questions, use different methods, use different language models. And it's very, very different to sort of put together and say, okay, so what does the evidence base as a whole say? So there's, as Anna mentioned, studies within a review. There are now becoming templates for carrying out some of these studies, where if we actually organize ourselves and say, okay, and it saves us trouble as well. It saves us work, that we can take a pre-existing template of how to do a particular validation study and then just use it. And if we use that and use them consistently, then we build a cumulative evidence base that we can do evidence synthesis ourselves on these methodology studies. And what that will mean is that we've got a much firmer evidence base on which we can develop best practice standards and then link and communicate with developers in terms of the expectations that we've got. So my last organization slide on this is the organizations, and we've got the evidence coming from reviewers doing reviews, the data. We've got the methodologists doing the validation studies, developing best practice standards, and then that can then feed into organizations who can pick up the best practice standards and then consider implementation standards and implementation and integration. How do you actually then put them into practice? So we've got a whole lot of guidance in terms of developing an evidence base here, but then actually what's absolutely critical is, at an organizational level, thinking about how we implement them, how we promote them, how we support responsible use of AI in different organizations. And of course, part of that is monitoring that. We don't just sort of write some guidance and leave it. We've got to consider active monitoring so that we know, we can chart progress and we can identify problems. So they went up today, 3 new papers on the open science framework, and that QR code should take you to them. There's document 1, which is recommendations for practice, and that goes through each of those roles that I've talked about and articulates the recommendations in a lot more detail than I've taken you through here. Document 2 then is a supporting document, which is around building and evaluating evidence synthesis tools, and also contains guidance about how to report evaluation studies. And then the 3rd document is a very user-facing document, which is around selecting and using evidence synthesis tools. So there's over 30 authors and organizations on these documents now. And we're very interested in feedback. That's why it's on the Open Science Framework. So do go and take a look and let us know what you think. We will be revising them again before too long, I'm sure. So at this point, I think I'm going to hand over to Ella.
So I'm going to be talking a bit more about applying these RAISE recommendations in practice, particularly what it means for authors or the evidence synthesists. But before I do, I just want to introduce the new Joint AI Methods Group. So this is a new methods group that launched in February earlier this year between Cochrane, Campbell, JBI, and the Collaboration for Environmental Evidence. The conveners of this group are all authors on RAISE, And the aim of the group is to guide and advise how AI will be implemented across the 4 organizations. And there will be differences to how AI is implemented. Each organization has differences in capacity, in resource, in structure, infrastructure. But as this is a global challenge, we felt it was important to collaborate and to align our approaches as much as possible. And so here you can see on the right-hand side the list of conveners and associate conveners who are involved in the group, and we have, as has been mentioned, quite a few on the call today. So some of the areas we're working on include defining best practice, particularly through our involvement in the RAISE project, the RAISE initiative. We also, as we are kind of that bridge from the best practice to implementation, we are focusing on capacity strengthening and AI literacy with things like position statements and frameworks. And these are ones that are of particular relevance to authors or editors so that the expectations about AI use can be clear. In addition to this, we've also started working with some of the AI tool developers. I think what we've seen is that there are some areas that AI tool developers could address to better help facilitate the use of their tools in a responsible and reliable way. So the first is ensuring that we have more public information on the systems and really clear terms and conditions. The second is ensuring that evaluations are publicly available and transparently reported. And the third is around making sure that strengths, limitations, potential biases, and generalizability, that information is clear and public. And the reason that this is so important is because this is the information that authors and editors really need to be able to make informed decisions about whether or not they should use a particular tool. And this will become increasingly clear over my next few slides. I'm going to highlight how practical steps can be taken by authors when they want to use AI in their evidence synthesis. So one of the most important messages for everyone to take home today is that AI and automation in evidence synthesis should be used with human oversight. AI should be a companion should be a companion and not a replacement to humans. And as James mentioned, evidence synthesists are ultimately accountable and responsible for their work. They've always been, this has always been the case for things like defining the review question or deciding what methods to use. And now it includes the decision about whether to use AI and how it should be used. And so the first step is really to make sure that it adheres to legal and ethical standards. And if it doesn't, then it's a no-go. You shouldn't use the AI. Paper 3 in that RAISE collection will help you navigate some of these areas. So some of the key things to think about are plagiarism and provenance. So how can you ensure that you don't represent the work of others? So that might be their words or their data or their ideas as your own without appropriate acknowledgement. Second, there's areas of copyright and intellectual property. And there's two parts to this we need to be wary about. The first is ensuring you don't breach copyright or license agreements by uploading content into an AI system when you shouldn't. But the second is also protecting your own IP. So if you use an AI system for your own work, you want to make sure that you don't unintentionally assign rights to your work to the system. Third are areas around jurisdiction and licensing. So making sure that you have, the access and the license to use an AI system. So for example, some tools may have limited rollout or may only be available in specific countries. And then we come on to the kind of terms and conditions of use, which, as James mentioned, can be tricky to navigate. Some of the tips here, again, these are all mentioned in the third paper of the RAISE series, are to pay particular attention to clauses around data ownership or data handling, which may include references to whether the tool trains on your data or retains it. We strongly recommend that you don't use systems that gain the rights to your content including the rights to use or distribute or repurpose or adapt or anything like that. And that might be within the system and to train the system. What you want to do is look for strong privacy controls and clear terms and conditions around privacy. Ideally, we want systems where you could disable data collection for training, or that have the ability to turn off or delete the history within the system. Some organizations or institutions may have access to private or enterprise versions of AI systems, and these generally offer greater privacy and security features than your more kind of free and public and open AI systems. So, for example, the Pro version of Claude guarantees the input won't be used for LLM training, whereas the free version does. And then finally, some of the ethical considerations, which might involve breaching informed consent or adhering to data protection laws. So yeah, again, RAISE 3 has tips and guidance on how to start navigating these. Next is that the evidence synthesis, as evidence synthesis, we can and we should use AI as long as we can demonstrate that it won't compromise on the methodological rigor or integrity of our synthesis. You need to be really critical of the evaluations of an AI system so that you can understand its limitations and whether it can be applied to the context of your review. And what's important here is having really clear justification and being able to demonstrate that the tools are methodologically sound, that they don't undermine the trustworthiness or reliability of your syntheses or your conclusions. And third, that it's appropriate to use a specific AI tool for the context of your evidence synthesis. And as we've seen, the second and third papers in the RAISE collection provide more guidance on this, including kind of best practice for conducting evaluations and building that cumulative evidence base. There's a table on an overview of the current kind of state of the art of AI tools across evidence synthesis, as well as guidance on how to select and use AI tools that's more focused for authors. And finally, any AI that makes or suggests judgments should be fully and transparently reported in the evidence synthesis manuscript or report. And so what I mean by judgments is things like, is this study eligible for my review? Any appraisals, so that might be risk of bias assessments, the extraction of data about a study or its results, the synthesis of data, or even the drafting of text for different sections in your review, or summaries like abstracts and plain language summaries. And here we have a snapshot of the Cochrane editorial policy on AI generated content. And Cochrane adheres to the PRISMA reporting standards, which include items on reporting automation tools that have been used at different stages of your evidence synthesis. And in general, what authors should be reporting on is the name, the version, and the dates that the AI tool was used. You also need to talk about the purpose for using AI and which parts of the synthesis were impacted. Best practice here involves things like citing or referencing user guidance, or reporting how it was used in the review, along with any modifications that were applied. And then there are these two vital elements to justifying the use of an AI tool. First, that the tool does what it says it does, and that it does it to a good enough standard, that it's methodologically sound, which can be justified by citing and referencing the evaluations. And the second is to showcase that it's appropriate to use the AI tool in the context of your specific synthesis. Some of the ways of doing this include making the inputs or the kind of prompt development and outputs publicly available. And this justification, this two-stage justification of it does what it says it does and that I can use it in my own synthesis, these are the basis for ensuring human oversight on AI use within your evidence synthesis. And then finally, in terms of reporting, if you have any financial or non-financial interests in the tool, these should be declared along with any funding sources. And so this is just a summary of the 4 points I just mentioned. Our new joint AI methods group is also working on a position statement to clarify these points for authors and to provide more guidance on how to report AI use fully and transparently. So watch this space for more details soon. And we're only a few months in as a methods group, and we're very much listening to community needs. What are the areas that we need that we should be prioritizing so that we can better mainstream AI through the 4 organizations? So some of the things that are on our agenda include organizational approaches to assessing AI tools and systems. Frameworks to understand whether an AI tool can be used in a specific evidence synthesis. We've obviously mentioned how important this is, and kind of breaking down those steps for authors will be is a priority area. Third includes things like defining classifications for AI use in AI evidence synthesis, and defining which are acceptable to use in what situations. We also want to work on defining acceptable accuracy standards for AI systems, as well as other kind of training and resources that will support their use. And so one of the areas that has started moving is around the acceptable accuracy standards. So just before I finish, I just want to plug this survey. It just launched yesterday. So what we currently don't have is consensus on how kind of correct evidence synthesis should be. And that's with current best practice, so human only. So we've already heard from Anna there, right, that the gold standard of humans isn't always 100%. Humans may be affected by the level of expertise they have in synthesis methods or in the domain itself, or it could be just around fatigue or general wellness. So having a kind of consensus around the accuracy we should be aiming for, as best practice is important, and then also understanding how that might change if we add AI. And we also don't have consensus around what an acceptable impact of errors might be. So, and whether that would change if the different types of evidence synthesis. And so this survey, which has been developed as part of the Wellcome funded Destiny project, aims to help better understand this. And it is a first step in collating expectations, and those expectations will inform future work. So we think it might raise more questions than it answers. And therefore, we really do encourage everyone that is listening today or that listens to the recording to please complete this survey and be part of the discussion. And so to summarize, we need AI. Efforts are underway to support the wider adoption of AI, and that's to be more sustainable. But AI also needs us. It needs the evidence synthesis community. There's a danger that the misuse of AI could increase bias and reduce reliability in evidence synthesis. And therefore, every individual and organization from across that ecosystem needs to think about what hats they wear, what roles they meet, and how they can contribute to responsible AI use. AI is here to stay, and so the question isn't whether we should use it, but how. And we all need to ensure that as the field evolves, we don't compromise on those core principles of evidence synthesis, on rigor, transparency, and reproducibility.